Picture this. A glowing ball of light, maybe tiny, like a marble, sometimes, well, huge, like a car, just floating in the air. People have seen them for, like, centuries, even claiming they drift through walls.
Right.
We're talking about ball lightning, a real head-scratcher of a phenomenon.
Absolutely. It often pops up around thunderstorms, sure.
Yeah, but it sticks around way longer than a regular lightning flash.
And it's definitely not, your typical spooky light like St. Elmo's fire or will-o'-the-wisp.
Exactly.
It's truly remarkable, isn't it? For generations, these stories of luminous spheres have just kept coming up.
And even now, with all our science.
It still fascinates.
Yeah.
The 2014 publication of an optical spectrum, basically a light fingerprint, right?
Yeah.
From a suspected ball lightning event, along with that high-speed video,
Yeah.
that was a real landmark.
Huge deal.
Yet the actual hard scientific data we have on this,
Yeah.
it's still surprisingly thin on the ground.
Even though labs have made things that look kind of similar.
Exactly.
Yeah.
Even with those lab results, connecting them to the real thing is tricky.
Right. So, for this deep dive, we've plunged into historical accounts, scientific studies, even some eyewitness testimonies. Our mission, to try and get a handle on what we know about ball lightning's traits.
Explore those captivating historical sightings.
Dissect the few direct measurements we actually possess.
Examine what's been cooked up in labs.
And finally, explore the many scientific ideas trying to explain this thing.
Okay, let's dive in. Characteristics first. Sounds like a real grab bag of descriptions.
Totally. The sheer variety in the reported characteristics is, well, it's one of the biggest challenges.
Yeah, you hear about it moving every which way, up, down, sideways.
Just hang in there sometimes.
Right, or with the wind, sometimes against it, even spinning.
And how it interacts with things. That seems really inconsistent, too.
Oh, definitely. Some say it's drawn to objects, others say it ignores them completely.
And then repulsion.
Yeah, and get this, some accounts describe it passing right through solid stuff, like wood or metal.
Without leaving a mark. Seriously.
Apparently. While others talk about it causing melting or burning, it's confusing.
It really runs the gamut, doesn't it? You've got connections to power lines.
Sightings way up high over 1,000 feet.
And it shows up in the thick of thunderstorms and in completely calm weather.
Right. And the look of it. It's a real light show. Transparent, translucent, every color imaginable.
Sometimes just a steady glow, other times spitting out flames or sparks.
Exactly. And not always a perfect sphere either. We hear about ovals, teardrops.
Rods and discs even.
Yeah. But it's worth stressing, again, this is definitely considered different from St. Elmo's fire.
That continuous glow you see on pointy things, right?
Precisely. And the way these things disappear is just as varied.
Some vanish in a flash.
Others just fade slowly. Sometimes they seem to get absorbed into something.
Or just pop out of existence.
And then you've got the dramatic exits, loud bangs, sometimes causing actual damage.
Wow. Even how dangerous they supposedly are. It's lethal to harmless.
It really underscores how tricky it is to nail down exactly what we're dealing with.
But way back in 1972, there was a study that tried to find some common threads, right? Even knowing eyewitness accounts can be, well, iffy.
That's right. They tried to pin down a typical event.
So what did they figure out was typical?
Well, according to this review, a typical ball lightning often shows up around the same time as a regular cloud-to-ground strike.
Okay.
It's usually described as round or maybe pear-shaped with fuzzy edges.
And size?
Size-wise, think somewhere between, say, a few inches to a few feet across. Most often around the size of a basketball, maybe.
Okay. Visible? Brightness?
Brightness-wise, imagine a regular light bulb visible even when it's sunny out.
And colors?
Red, orange, and yellow seem to be the most common colors reported.
How long do they usually last?
Anywhere from a single second to over a minute, apparently keeping a pretty steady brightness the whole time.
Okay, so that gives us a bit more of a central picture to work with, sort of a baseline.
A tentative one, yeah.
What about how they move and, what they do?
In terms of movement, a few meters per second seems common, often moving horizontally.
But not always.
No, they can also go up, down, stay still, or move erratically. And they're often seen rotating.
Interesting. Do people feel heat from them?
Rarely, actually. People rarely report feeling heat, though sometimes heat can be released when they disappear.
And this attraction to metal.
Yeah, there's this reported tendency to be attracted to metal objects. Stories of them following wires, fences.
Train tracks.
Even train tracks. And then you have the really strange cases of them appearing inside buildings.
Or airplanes.
Or airplanes, passing through closed doors and windows, or the metal fuselage.
Without causing any damage.
That's what some reports claim.
Huh.
Finally, they usually vanish quickly, either silently or with a bang.
And the smell. People report smells.
Often, yes. Things like ozone, that kind of fresh electric smell after a storm, or burning sulfur, or nitrogen oxides.
So even the typical description still sounds pretty bizarre.
Absolutely.
Now let's delve into some of these historical accounts. It's incredible how far back these sightings go.
It really is. It even makes you wonder if ball lightning might be the basis for some old legends, you know?
Like the Ankh-Main, those mythical lights.
Exactly, those luminous balls from South American folklore. And it's not just stuff from centuries ago.
Right. There was that study in 1960.
Yeah, looked at people working at Oak Ridge and Union Carbide nuclear facilities.
And what, like 3 to 5% said they'd seen it?
Something like that, yeah.
Yeah.
Surprisingly high. And a Scientific American article summarized a broader study suggesting maybe a 5% global sighting rate.
Wow.
And another study even looked at over 2,000 reported cases. So this isn't just a few isolated stories.
That's a lot of people. So let's look at some specific historical examples. One of the earliest potential mentions, Gervase of Canterbury, 1195.
Yeah, Gervase, an English monk, he wrote about a marvelous sign near London, a thick, dark cloud that released a white substance, which then formed a round shape below it. From this round shape, a fiery globe then fell towards the river.
Sounds suggestive.
Some modern researchers, like Tanner and Gasper, think this sounds a lot like an early description. They do into the white substance, the spinning fiery sphere, its horizontal movement.
Fascinating. And we have the Great Thunderstorm of Widecombe in the Moor, 1638. That sounds pretty intense.
Oh, it was truly destructive. An 8-foot ball of fire reportedly struck and went inside a church.
Inside, yikes.
Caused a lot of damage, injured about 60 people, and sadly kills 4.
Oh, wow.
Witnesses described huge stones thrown from walls, beams breaking, pews smashed, windows shattering.
Chaos.
Total chaos.
There.
And the church filled with this nasty sulfur smell and thick, dark smoke.
And the ball itself.
It supposedly split into 2. One part left through a broken window, the other just vanished inside.
And people back then thought.
Well, understandably, they thought it was the work of the devil or, divine punishment.
Makes sense for the time. Moving ahead. 1726, a ship, the Catherine and Mary.
Right. A fellow named John Howell wrote about a large ball of fire falling from the sky in the Gulf of Florida.
Falling, not floating.
Falling, according to him. It supposedly hit their ship, broke the mast to pieces.
Seriously?
Damaged the main beam, the planks below the waterline, the deck.
Yeah.
Tragically, one man was killed, another lost a hand.
Terrible.
They even mentioned that if it hadn't been raining heavily, the sails probably would have caught fire.
Then there's the HMS Montague in 1749 with Admiral Chambers. That sounds like a really close call.
It certainly does.
Yeah.
Admiral Chambers saw this large blue ball of fire about 3 miles off.
Oh, okay.
They lowered their sails, but a ball came towards them quickly, rising straight up near the ship.
And then?
Then it exploded with a force they compared to 100 cannons firing at once.
Whoa.
Left a strong sulfur smell behind. Shattered the main topmast, damaged the main mast all the way down.
100 people.
Yeah, 5 crewmen knocked over, 1 badly hurt. Just before it exploded, they said the ball was the size of a large millstone.
Massive. And we can't forget the unfortunate George Richmond in 1753. A sobering story.
Very much so. Professor George Richmond in Russia doing a kite experiment, like Franklin's.
Yeah.
Ball lightning appeared, traveled down the kite string, and tragically struck him right in the forehead. Killed him instantly.
Awful.
Left a red mark, his shoes were blown open, clothes burned, his assistant was knocked out, the room itself was damaged, door frame split, door torn off hinges.
Just terrible. There are so many more accounts through the centuries, aren't there?
Oh, loads. HMS Warren Hastings in 1809 attacked by 3 balls of fire, 2 deaths.
Ebenezer Cobham Brewer in 1864 describing globular lightning.
Wilfred de Fonville in 1875 collecting about 150 reports. He noted their attraction to metals in different colors.
Even Tsar Nicholas II saw one.
As a child, yeah. Recounted seeing a fiery ball in church during a thunderstorm.
It really paints a picture of a recurring widespread thing.
Absolutely.
Yeah.
De Fonville's collection is really interesting. Examples like a green ball here, a bouncing ball there.
A bouncing ball.
Yeah, in Paris, apparently, and a destructive one in Salignac. He also mentions that incident at a church in Stralsund, where an exploding ball seemed to create smaller secondary exploding balls.
Wow. And Tsar Nicholas's childhood memory adds a really personal touch.
It does. almost surreal.
And it keeps happening in more recent times, right? Aleister Crowley saw one in 1916.
Yeah, it described globular electricity during a storm in New Hampshire. Stationary, then a sharp explosion, felt a slight shock.
And R.C. Jennison on that airplane in 1963.
Saw a glowing sphere emerge from the pilot's cabin and just travel down the aisle. Can you imagine?
Wild. And then loads of others. Paris fireplace, 1852. Uppsala window hole, 1994.
Guernsey aircraft strike in 2005 with fireballs on the ground afterwards. Log and air flight in 2014. These sightings don't seem to be stopping.
No, they really don't. The sheer number and the spread over time and place, it really suggests we're not just dealing with misinterpretations.
Exactly. Something real, though elusive, seems to be happening. The consistency in some descriptions, despite all the variation, points that way.
Which brings us to that incredibly rare instance in 2012. Natural ball lightning actually measured directly. That must have been huge.
A very significant moment, yes, even though it's just one event. In 2014, scientists published the optical spectrum that light fingerprint recorded in Tibet.
It was luck, right? They weren't looking for it specifically.
Pure luck. They were studying regular lightning. They got 1.64 seconds of digital video showing it forming after a ground strike and then fading.
And high speed, too.
A high-speed camera caught the last 0.78 seconds in much more detail.
So what did this direct observation tell us about what this particular ball lightning was made of and how it behaved?
Well, the big finding was detecting signatures of neutral atoms, silicon, calcium, iron, plus nitrogen and oxygen.
Silicon from the ground.
That's the implication,
Yeah.
and it's quite different from the lightning strike that created it, which was mostly ionized nitrogen.
How did it move?
It moved horizontally, about 8.6 meters per second. Estimated diameter was about 5 meters, and it traveled maybe 15 meters in that short time.
And there was some kind of flickering.
Yeah, they saw the light intensity and the oxygen-nitrogen signals fluctuating 100 times a second. 100 hertz.
Any idea why?
They wondered if it might be linked to nearby high-voltage power lines, which would operate at 50 hertz. Maybe some interaction.
Interesting. And the temperature? Hotter or cooler than lightning?
Cooler. They estimated the temperature to be lower than the parent lightning, somewhere below 15,000 to 30,000 Kelvin.
Still incredibly hot, but cooler than lightning itself.
Right. The data seemed to fit with this idea of vaporized soil and also suggested the ball was sensitive to electric fields.
The silicon finding is really interesting, especially thinking about theories we'll get to.
Definitely a key piece of data.
But before that, let's talk about trying to make ball lightning in the lab. Scientists have been trying this for ages. How's that gone?
Well, attempts to recreate it have a long history, yeah. But whether these artificial creations are the same as the natural phenomenon, that's still a big question mark.
Nikola Tesla apparently made some.
He reportedly could make small, maybe inch-and-a-half-sized balls, though he seems more interested in other things.
There's even an international committee on ball lightning.
There is, yeah. They hold regular meetings, symposia, shows the ongoing scientific interest.
So what are some of the interesting lab experiments that have produced these ball lightning-like effects?
Well, one method uses focused microwaves. Researchers described creating plasma fireballs by making microwaves interfere inside a special container.
Okay.
Others, like at the Max Planck Institute, have reportedly made similar effects by discharging high-voltage electricity in water.
Water discharge. Interesting.
Then you've got the more maybe well-known experiments using household microwave ovens.
Right. The grape thing or matches.
Exactly. People have made small, glowing plasma balls that way. Researchers studying those found they contain tiny nanoparticles.
Nanoparticles.
And perhaps most relevant to that silicon finding.
The natural one.
Yeah. Are the experiments where they shock silicon wafers with electricity?
What happens?
It vaporizes the silicon and creates small, glowing orbs. Scientists in Brazil have even reported consistently producing longer-lasting balls using this method.
So silicon keeps popping up.
It does seem to be a recurring theme in some of the research.
It's amazing that so many different methods can produce things that look similar, though.
It really is, which adds to the puzzle, in a way.
Now let's get to the big question. Why? What are the scientific explanations proposed for ball lightning? Sounds like there are a lot of ideas.
You're absolutely right. There's no single explanation everyone agrees on, not even close. And scientists have been proposing theories for, well, over a century.
Early proponents?
People like William Snow Harris and Francois Arago were among the first trying to make sense of it.
Okay, so what's a leading idea now? The silicon one.
The vaporized silicon hypothesis is definitely a major contender. The basic idea is Lightning hits the ground.
Vaporizes silica in the soil.
Right, creating pure silicon vapor. As this cools, it condenses into tiny charged particles, an aerosol.
And it glows because...
It glows as the silicon reacts with oxygen oxidation. That 2014 measurement from Tibet really boosted this theory.
The dirt clod hypothesis.
Sometimes called that, yeah. There are even ideas about how silicon might be stored in the soil, maybe as nanoparticles of C, CO, or SEEK.
That definitely ties in nicely with the Tibet data. What are some other main theories?
Another idea is the electrically charged solid core model. Imagine a positively charged center,
Okay.
surrounded by a layer of electrons with a really intense electromagnetic field in between holding it together.
And microwaves, they seem relevant from the lab stuff.
Yeah, the microwave cavity hypothesis. Kapitsa proposed this originally. The idea is that ball lightning is a glow discharge powered by microwave radiation.
Guided down from lightning clouds somehow.
That's the idea, yeah. With the ball itself acting like a resonant cavity, trapping and amplifying the microwaves.
Bit like a tiny natural microwave oven?
Sort of. There's a more complex version too, the Handel-Maser-Soliton theory, involving a giant natural maser in the atmosphere as the energy source.
Laser. Like a laser with microwaves.
Essentially, yes. And more recently, 2017, scientists proposed microwaves could get trapped inside a plasma bubble created by high-speed electrons from a lightning strike.
So microwaves keep popping up. What about the Soliton hypothesis? That sounds different.
It is. The Soliton hypothesis suggests ball lightning is like a detached form of St. Elmo's fire.
Attached? How?
The idea is that a free-floating ball of ionized air can strengthen the surrounding electric field enough to keep itself ionized. It becomes a self-sustaining wave of energy, a soliton.
Okay, a stable wave.
Research looked at specific molecules, like metastable NO ions, maybe playing a role linking it to the afterglow sometimes seen in microwave generators.
And this has been developed further.
Yeah, suggesting it could be based on complex oscillations of charged particles in plasma. Maybe even, and this is pretty out there,
Go on.
maybe even leading to a kind of superconductivity within the ball.
Superconductivity in ball lightning. That's a wild thought.
It is pretty speculative, yeah.
Are there any other completely different ways of looking at it?
Definitely. There's the idea of it being some kind of combustion happening within a swirling vortex of air.
Like a fire whirl?
Maybe something like that.
Yeah.
Then the nanobattery hypothesis
Nanobatteries.
suggests ball lightning is made of incredibly tiny composite nanoparticles acting like miniature batteries, short-circuited on the surface, causing the glow.
Wow. What else?
The buoyant plasma hypothesis. This came up in that declassified UK report, Project Condign.
What did they suggest?
These are formations of charged plasma that float due to some novel atmospheric phenomena, maybe even linked to meteoroids entering the atmosphere, though that's quite debated.
Meteoroids. Okay. And what about some of the more psychological explanations?
Well, there's the thought that maybe some sightings are actually hallucinations.
Hallucinations caused by what?
Caused by the intense magnetic fields from lightning strikes. The idea is they might trigger something in the brain's occipital lobe, like a mild epileptic seizure or magnetophosphenes.
Like seeing stars.
Kind of. Experiments using transcranial magnetic stimulation have produced similar visual effects.
But that doesn't explain.
Exactly. It doesn't really explain the physical damage sometimes reported, or when multiple people see the exact same thing independently.
Right. Any other less conventional ideas?
There's the Rydberg matter concept. This suggests ball lightning could be made of a really exotic state of matter.
Rydberg matter.
Yeah, where atoms are highly excited and loosely bound together. It could potentially last for a long time and then decay explosively.
What did Tesla think it was?
Early on, Tesla himself thought it might just be very hot, highly rarefied gas, almost a vacuum.
Simpler idea.
Then there's an electron-ion model. Charged ions inside, electrons spinning around the outside, creating a magnetic field, keeping it stable.
And the electrochemical model.
That suggests it's an air plasma with ongoing chemical reactions, maybe nitrogen oxidation fueling it. This could lead to tiny water droplets forming around ions.
Which stabilizes it.
Possibly, yeah. And might explain some of the weird movement and behaviors, like passing through glass. It needs a delicate balance of conditions.
And there are still more hypotheses.
Oh, yeah. Spinning electric dipoles, electrostatic Leyden jar models, though those have been criticized, fractal aerogels, plasma superconductivity again, collective electron oscillations. It really highlights how much we're still just trying to figure this out.
That's quite a list of possibilities. So many different angles trying to explain this really, really unusual phenomenon.
Yeah.
Feels like we've truly taken a deep dive into the world of ball lightning today.
We certainly have. We've looked at the huge range of characteristics reported.
Those compelling historical stories spanning centuries.
That crucial, though single, direct measurement.
The attempts to recreate it in the lab.
And, yeah, the sheer number of scientific ideas trying to make sense of it all.
And yet, despite all of this, the eyewitness accounts, the scientific investigations, all these different theories.
We still don't have a clear, definitive answer.
No. Ball lightning remains one of nature's most stubborn mysteries.
It really makes you wonder, doesn't it? With centuries of people seeing this and all the advanced tools we have today, why does it remain so stubbornly unexplained?
Yeah, what are we missing?
Could it be we're missing some fundamental piece in our understanding of atmospheric electricity? Or maybe,
Something more radical.
as some of these more unusual theories suggest, are we maybe even on the edge of discovering new physics? Phenomena we just don't fully grasp yet.
It certainly leaves you with a sense of awe.
And hopefully sparks some curiosity, for you to maybe explore this fascinating atmospheric puzzle further on your own.